Hi everyone. So today we will solve this problem, path sum 3. So we are provided with a binary tree and an integer called target sum, and we have to return the number of path where the sum of the values along the path is equals to this target sum, right? And one important condition is that path may or may not start from the root and it may or may not end at the leaf. Okay, that is the condition. So let's look at the first example. So this circled path, you can see the sum of all these path is 8, right? So if you notice for this 5, 8, 5 plus 3, the sum of this path is 8. So this is one of that path. Here also 5 plus 2 plus 1, here also the sum of the path is 8. Minus 3, 11, here also sum of the path is 8. So there exist 3 path. Okay, so that is our answer. So let's look at the solution, how to solve this problem. So let's take the same example. So here target sum is 8, all right. And to solve this problem, we should understand one concept, which is the prefix sum. Okay. So suppose we take this path. So in this path, we have elements 10, 5, 3, 3. All right. And these are connected like this. Okay. And we know that this path has sum 8. Okay. So how do we find, just by simply traversing this path, how do we find that there exist two nodes such that their sum is 8? So what we can do is we will be using something called map. So in this map, we will store two things, value and its corresponding frequency. All right. So whenever we will traverse this path, we will store the current sum. So current sum is simply whatever the values we encounter, we keep on adding them and we keep on updating their value and frequency in the map. What we have to do is we have to traverse this, and first of all we encounter 10. It is not in the map, so it will become 1. Then we go to 5. Okay, current sum will be 15. We are simply adding, right? It will be 1. Then we go to 3, 18, 1. Then we go to next element. It will be 21, 1. All right. So this is what we have to do. This is the simple step. Now the important step is, while saving these values in map, we also need to check one thing, that the current sum which we have minus the target sum, this value, does it exist in map or not? All right. So if you notice, when we are at this node, the current sum will be what? 18, 10 plus 5 plus 3, and the target sum is 8. If we subtract, we get 10. And if you notice, this value is already present in the map, right? That means whatever this frequency is of this particular element, that is the number of elements or the number of path which have sum 8. So here you can see the value is 1. So that's why there exists only one path, 5 and 3. There is no other path with sum 8. So why does this work? So let's try to understand what exactly we are saving in the map. So instead of representing map in this simple value, if we represent this map as nodes, from that what I mean is, this is the value, this is the frequency, same. This first value 10, what does this represent? It represents a node 10, which has a frequency 1. Then 15, what does it represent? It represents this path 10, 5, which has a frequency 1. The next element, what does it represent? It represents 10, 5, and 3. And the next, it represents 10, 5, 3, and 3. Frequency is 1. Now, using this table, okay, so what we are trying to do, we are simply subtracting 8 from every one of the path, right? We subtracted 8 from this path. So if there exists any path such that their sum is 8, okay, so basically some nodes will get removed from that path, okay, and if we are removing some nodes from a path, the remaining node must have some sum which must exist in the map also, right? So in this path, if you see 10, 5 and 3, if I am subtracting 8, it is same as deleting 5 and 3. If we are deleting 5 and 3, the remaining path, whatever we have, we must have stored their sum in the map, because that's what we are doing in every step, right? So if that is the case, if this value is present in the map, that means yes, there exists some path after removing these two nodes, okay, so we can see this is that path, right? So this is the simple logic. That's what we have to do. Okay, so let's try to look at the pseudocode. All right, so this is the pseudocode. So here if we see, we have the solve function, which is the main function. Okay, so whatever I mentioned, that's what we are doing. So first of all, this is the base condition. If root is null, we don't need to do anything. And we are updating current sum. Okay, so what we are basically doing in this solve is we are traversing the binary tree, and we are updating the current sum, updating the count, that is our answer, updating the map, okay, and traversing, and then updating the frequency at the end. So let's see how it is going. So we are updating the current sum. Okay, so suppose we are at node this, so current sum will get updated to 18. Current sum is equals to 18 now here. Now we will check current sum minus the target. Target is 8, target sum is 8, so 10 minus 8, it will be 10. Does it exist in map? Yes, it does exist in map. So we will simply add that value in the count, whatever the frequency was. We created one map earlier, right, where 10 has a frequency 1. So this we will add in the count. We will add it. Okay. Once this is done, then we will check, does this new frequency 18 present in the map or not? Because whatever the current sum is, we need to update the map also. Since it does not exist, so we will add one entry. And also suppose this 18 was already present in the map. In that scenario, we will increment the frequency. Okay. Once this updation of the map is done, we are simply traversing here the left and the right subtree. Okay. And once we have traversed left and the right subtree for any node, suppose for this node, we have traversed the left also and the right also. We have to reduce the frequency of the current sum in map. Okay. Why? Because when we have traversed left and right for this node, what we are saying, we are backtracking to 5. When we are backtracking to 5, so the current sum which was 18 earlier, when we backtrack, it will change to what? It will change to 15, because this 3 will be deleted now, right? Because when we backtrack, we will never come to this path. Our new path will begin from here. So this node 3 will never be the part of our path. So why should we include node 3 in our current sum? Okay. So that's why whatever the frequency of 18 was, it will get reduced by 1. So we know earlier it was 0, not 0, it was 1. So we will reduce it to 0. If it was 5, reduce it to 4. So this is it. This is what we have to do. So this is the simple pseudo code. So let's look at the code. All right, so this is the code. This is our solve function, and we are passing some parameters over here. This is the tree. This is our final answer, which is passed as a reference, because we don't want to create new copy with every recursion, right? This is the current sum. This is the map. Here also we have to maintain a single copy. That's why reference. And this is the target sum. So this is the base condition when root is null. So we don't need to do anything. And with each node, so basically in this tree, if you notice at the end, we are simply traversing it, right? We are going to the left subtree, then we are going to the right. This is simple traversal. And these steps are just whatever we are doing with the each node. Okay. So here with each node, we will update the current sum. So suppose we were at 10, then we move to 5. So current sum will get updated to 15. Okay. And whatever the new current sum is, we need to check if after removing the target sum, there exists some entry in the map or not. If there exists some entry, we will add the frequency of that particular entry. Otherwise, we will not do anything. Then in this part, we are simply updating the map. So new value is 15, 10 plus 5, 15. If it exists in the map, increment the count. If it does not exist in the map, simply initialize it the first time, right? And then we will traverse left and right. All right. So in this last part of code, we are simply decrementing the current sum frequency. Why? Because if we are at node number 3 and left and the right subtree we have traversed. So this path 10, 5, 3, which basically means value 18. Okay. Its frequency is no longer needed because we have traversed the left and the right subtree. For this subtree, the path will be 10, 5. Okay. This it will not include 3. That's why this current sum, whatever we have, 10 plus 5 plus 3, we will decrement it before backtracking, before going to 5. So we are simply decrementing it. Once this is done, this answer will store the number of such path. So that's what we have to return. So one important thing here, we have initialized target 0 to 1. Okay, so this is to handle one edge case where suppose the target sum was 10 and here also the first root node is 10. In that scenario, right now, map does not have any entry. So if I do current sum, which is 10, minus the target sum, which is 10, I will get 0. And 0 does not have any entry. So this part of the code will not be executed because this will fail, correct? So to handle it, we have explicitly added this target 0 to be 1, okay, to handle such scenarios. All right, so I will share the link to this code. You can check it out. And yeah, thanks for watching the video. Bye. Take care.